Jnanam paramam dhyeyam. Knowledge is supreme.
We have come to tutorial 3 and we will be discussing few problems on linear vector space. And in previous two tutorials, tutorial 1 and 2, you have already seen few problems on particle in a box, and there were several problems wherein you find out the energy eigenvalue, wave function, etc. I hope you have already tried by yourself those problems, but if you have not tried, please go back and try it at least once, and it will be very helpful to you. So now we will start with third tutorial, in which you have few problems based on linear vector space, and let us start doing the first problem. So in the first problem, and here there are these are all more math oriented problem where you have to solve few steps, and we can start with the first problem, which says that there are two normalized ket given to you and some definitions of these kets in terms of a new ket is given. So we have to find out the norm of the two kets. So first is ket x and the other is w. So you have to determine the norm. So we know that the norm, just a recap, norm of a vector say x is given by square root of x on x, which is also represented as norm x. Okay. So we have to evaluate the norm of these vector x and w, and we know that x in terms of the normalized eigenkets v1 and v2 is 2v1 plus 2 minus 3i. So this is the first one in terms of v1 and v2. Now in order to evaluate this, we will have to start by doing x on x. So this would be just simple, just one example to illustrate. I will solve this completely, the others I will not give in between steps. So here this is a ket x. Now you have to calculate the bra of x, this is the bra of x. So in bra and ket notation, the norm is represented in this manner. So now ket will become bra, this normalization or this number will remain as it is, and the complex number will be a complex conjugate, you have to write. So 2 minus 3i will become 2 plus 3i times this bra. This is the first term, and the second term would be 2v1 plus 2 minus 3i v2. Okay. Now it is very simple to evaluate this. This will give me 4 v1. Let me calculate these terms, then we write the cross terms. Square term will give me, this will give me 2 plus 3i into 2 minus 3i will just give me 4 minus and minus plus. So 4 plus 9, that is 13 v1 v2 on v2. Okay. And we know that these are normalized eigenkets. So the norm of this would be 1. Okay. And then the cross terms would be 2 into 2 plus 3i, this with this will give me v2 v1 plus this on this will give me v1 v2. Okay. We are also given in the data that v1 on v2 is nothing but I by 2, and so the complex conjugate of v1 and v2 will be, this will be minus I by 2. So I will use this. We have to calculate for x on x will be simply 4 plus 13. So we have here, we have seen here you had 4 from here, 13 from here, and then you have the other terms, that is 4 minus 6i is one term from here times minus I by 2 plus we have 4 plus 6i into I by 2. So, this would simply give me 23. You add up all this and you obtain the norm of x is square root of 23. Okay. So, this will give me this result. Okay. So, we have calculated the norm of x, which will be now square root of 23. This is what we obtain by calculating norm of x. Similarly, try calculating norm of w. In a similar manner, you can just calculate the norm of w. The next part of the question is evaluate norm of x on w. So, x on w, same way we will take the x term, which is 2 v1 plus 2 plus 3i v2 on, we have w as 3 minus 2i and v1 plus 2 v2. Okay. So, this can also be easily evaluated. You have v1 on v1 will give me 1, this will be the term, we have to multiply this coefficient 2 into 3 minus 2i. Here I have 2 plus 3i into 2 and v2 on v2. So, this will give me what? This will give me 6 and 4, 10, and this will give minus 4 and plus 6. So, plus 2i, and the cross terms would give me, I just have to evaluate these. So, this will give me 4i by 2, that is minus 2i. Okay. v1 v2 is plus 2i, and the remaining term same way I will have 6 minus, I will have to evaluate 6 minus, this will be plus 6. Okay. So, this will give me minus 6i plus 5 by 2. Okay. On simplification I obtained this. When you simplify this further, what you obtain is x on w comes out to be 25 by 2 minus 2i. Okay. By just simply adding the real and the imaginary part. Now, in the second part you are asked to find out, okay, this would be nothing but the complex conjugate of the one which you have calculated x on w. So, this can be simply written this way. So, it will be a good exercise to check this. Okay. So, just check this and find out whether you obtain the same answer. Now, in the next problem, what we have here is that you are given 3 eigenkits. Okay. You are given 3 eigenkits. They are E1, E2 and E3. Okay. 3 eigenkits are given to you such that you are given the relations of each eigenkit with each other respectively, and using the Gram-Schmidt procedure you have to construct an orthonormal basis of these eigenkit. So, in order to calculate the orthonormal sets of these 3 kits, what one does is used Gram-Schmidt, which will project out each component in terms of the orthonormal vectors. So, now to start with, we have the first, we start writing let, so this is problem number 2, let u1 kit, u2 kit and kit u3 be the orthogonal kits. We have to obtain U1 in terms of these gets E1, E2, E3, U2 in terms of these gets E1, E2, E3, and similarly for U3. So we start doing by Gram-Schmidt. So by Gram-Schmidt procedure, what one does is, now you start with U1, and again just a remark that you can start with any of these. I mean U1, U2, U3 is just a representation of 3 orthogonal sets of eigenkets. So you can start by representing U1 in terms of E1 or E2 or E3 first, it does not matter, it will give you different sets of eigenkets. So I start U1 by writing U1 as E1 norm of E1. Okay. So we have calculated the norm. We have seen already what is the norm of a vector. Okay. So now I have started with U1 in terms of the eigenket E1. So this will be simply, now we have given that E1 on E1 is nothing but 2. Okay. So we have to calculate the norm of E1. Okay. So this will be nothing but square root of E1 on E1, which is nothing but 2, root 2. Okay. So we will have this as 1 by root 2 E1. Okay. So we have obtained U1 in terms of E1. This is one of the elements of the set of the 3 eigenkets. Similarly, U2, in order to obtain U2, you will write U2 in terms of E1, E2 minus, you project out in E1 in terms of U1. So you will have U1, E2, U1, you use a projection operator of U1 to project out the E2 component, and you will have to divide this by the norm of E2 minus U1, E2, U1. Okay. Now it is very easy to calculate this. Now once you know U1 in terms of, or rather you can write U1 here in terms of E1, and then you are given the relation between the 3 eigenkets when you operate one on the other. So what you can do here is, first let us see what will be U1 on E2. So U1, as we have just now seen, is 1 by root 2 E1 E2. Since we have real component, we can write this directly. The complex conjugate of E, get E will be bra E with this normalization factor, and you are given that this E1 on E2 is I by root 2. So this will be nothing but I. Okay. So again this U, I can write it as U2, I can write it as E2 minus, I have U1 E2. So I will just substitute for U1 E2. I am sorry, this has to be a get. So I will express this as, because I am writing this as a projection operator. So U1 E2 is, we have calculated it to be I. So it will be I times U1, okay, divided by, I will calculate the norm of this quantity which I wrote just now as E2 minus I U1. Okay. Now it is very simple to evaluate U1, we know. So now E2 on E2 we know the bra and ket of E2 is 2 and U1 on U1 is simply 1 by 2. What we have here in terms of U1 when we write, it is E1 which is nothing but 1. Okay. So, this will be 2 minus 1, because when I take the norm it will be square root of E1 square, norm of E1. Okay, let me write here, this will be nothing but E2 square minus norm of U1 square. So, how will I write? It will be U1 square, and in the numerator I have E2 minus U1 will be I by root 2 E1. So, the final answer for U2 I can simplify it to E2 minus I by root 2 E1, because this is 2 minus 1. So, you have 1. So, this is what I get for eigenket U2 ket 2, and ket 1 was this. U3 is nothing but E3, then the projection of U1 on E3, and again I wrote it wrong, okay, minus you have projection of U2 on E3, U2, okay, and the norm of this entire thing, that is E3 minus U1 E3, U1 minus U2 E3, projection of U2. Okay. Now, again we have to, what we have to do here is, first we will calculate what is U1 E3, okay, and U2 E3. So, just recall we have this U2. So, first we will do for U1. So, U1 E3 will be nothing but U1 is 1 by root 2 E1 E3, and what we have E1 E3 as 1 plus I, this was 1 by 2. Okay. And now what we do here is we substitute for U1 E3, U2 E3 will be nothing but, what was my U2? U2 was, this is my U2, sorry, times E3. So, this E2 on E3 we have it as 2. So, 2 minus I by root 2, and E1 on E3 is 1 plus I. Okay. So, that is nothing but, I can write this as, this will be minus I. So, this will be plus I. So, 2 plus 1 by root 2 minus I by root 2. So, this is my expression for U2 E3. Okay. So, this I will substitute in this expression. So, let us write this. So, this will be, I have now, and again U2 on E3 we have calculated, and U2 on E3 with, let me highlight this again, U2 on E3 and a U2, let me explicitly write this here as, this will be the expression 2 plus 1 by root 2 minus I by root 2, this will be the expression on U2. U2 was nothing but E2 minus I by root 2 E1. Okay. So, we can keep it as it is here, or we can just substitute it in the end. Okay. Mostly it will be good to substitute in the end because it is a lengthy expression. So, now let me come back here. So, here what we did was E3 and on U1. So, this gave us 1 by root 2 1 plus I, okay, and on U1 minus U2 E3, this is the expression I have 2 plus 1 by root 2 minus I by root 2 times U2. Okay. So, this is the numerator, denominator will be norm of this quantity. Okay. And now on further simplification, when you simplify this further and find out the norm, what you obtain is this norm comes out to be, let me write, you have to explicitly solve this, this will come out to be 2 root 2 minus 2. So, this is this norm. Okay. You have to calculate E3 on E3, which is nothing but 4, correct. This will simply give me minus 2 or 2 1, okay, this will give me 1, okay, because I have calculated U1 on this is 1 plus I upon root 2, square this and you operate again. So, what you obtain is just a factor of 1 and there is a minus sign. So, you will have a factor of 1. Then the square of this term, which will result in minus 5 minus 2 root 2. Okay. Then again you further simplify and obtain the denominator. So, the final expression for U3 will be E3 minus 1 by root 2 1 plus I. Okay. I can at this point I can substitute for U1, and what was my U1? This is my U2, this is my U1. U1 was 1 by root 2 E1. So, I have 1 by root 2 E1 minus I have this factor 2 plus 1 by root 2 minus I by root 2 times this factor U2 is this big expression which I showed you just a minute ago, this expression, okay, that is E2 minus I E1 upon root 2. This entire thing multiplied by this normalization factor, which is 1 by 2 root 2 minus 2. So, let me rewrite this expression completely. U3 is 1 by 2 root 2 minus 2 times you will have a factor of 1 by E3 minus 1 plus I root 2 into root 2. So, we are doing the simplification of this previous step. Here I will get 2. So, I have a 2, okay, on E1. So, these are the first two terms, and the second term we can keep it as it is, no need to simplify further. So, the last term will be, I will write here minus 2 plus 1 by root 2 minus I by root 2, you can see this, okay, times E2 minus I by root 2 E1. So, these are the three orthonormal sets expressed in terms of the eigenket E1, E2 and E3. So, let me put everything together. So, this is my E1, this is E2 and this is E3. Okay. So, you obtain U1 in terms of E1, U2 in terms of E2 and E1 and U3 in terms of this. So, you can check whether these are orthonormal sets of these three eigenkets. Similar problems we will do in the next part of this tutorial, a similar exercise. So, it will be good if you try these problems by yourself, you get hands on these problems. They are very simple, they can be solved, you try to do them in proper steps without skipping any steps initially. Later when you have hands on these problems, you can just skip steps wherever you can do things mentally. We will see in the next class the remaining tutorial.